Hello, and welcome to the Module 2.4 notes for solving equations with a variable on each side. Our objective for today is that I can solve equations with a variable on each side. I can solve equations by applying the distributive property, and I can prove that equations are identities or have no solution. So let's look at those two pieces that are two vocabulary words that I just introduced there. The first of which is an identity, and that is going to be an equation that is true for every possible value of its variables. And this is going to manifest, the way we're going to see this is we're going to have something like 5 is equal to 5, or 0 is equal to 0. Those are going to be identities. All right. Now our second one is a no solution. It's an equation that has no value of its variables that make it true. So the way we'll see this one shown is something like 5 equals 0, or -3 equals 2, right? Those are not equal to each other, so it is not, there are no solutions. Now, the implication here is that there are also going to be one solution options, and that would be the most common when you solve an equation and you get that x is equal to some value. That is one solution. That is what we are finding when we solve it, is the solution. So these are our other two possibilities, either an identity, where there are infinitely many solutions, or it's a no solution, where there is nothing that can possibly solve this. So let's work some of these. So let's take a look at letter A. We're going to start by drawing that line down our equal sign so we can kind of remember that we need to do things on, or the same thing on both sides of our equal sign. So I see that I have more x's on the right than on the left, and I always try to keep my variable positive if I can. So I'm going to start by subtracting 3x from both sides of my equation. And the 3x's cancel out, and I bring down the 4, and that's going to be equal to 5x minus 3x is 2x, and we bring down the minus 10 because nothing happens to it. Now I'm down to just a two-step equation. I want to add 10 to both sides, and I get 14 is equal to 2x, which means I divide by 2, and I find that 7 is equal to x. Now, if you had done this the other way and you had pushed your variables to the left side of the equation, you're going to be dividing by some negatives because you'll have -14 and -2x. But then once you do the division, you'll get your same answer of x equals 7. You're just going to have to make sure you're dividing the negatives properly. This is why I try to keep my equations to be as positive as possible, because I don't want to have to worry about the signs of negatives. And so if we keep the equation positive, we don't have to deal with that. All right, letter B. We're going to start off, we have our dividing line. And on the left side of this, I see that I have like terms that I need to combine. So that's the first step that I'm going to do. 5n minus 2n is 3n, and the minus 5 is still there, and the 7n plus 11 is still there. So my next step, I'm looking to see where do I have more of the variables, and there's more on the right. So I'm going to subtract 3n from both sides, and I'm going to get -5 is equal to 7 minus 3 is 4n, and then we have plus 11. Now I'm going to subtract 11 from both sides because I'm still trying to get that variable by itself. I get -16 is equal to 4n. And then my final step is to divide both sides by 4, and I get that -4 is going to be equal to n. And you can always substitute these in and check your work with the original equation on your own. All right, letter C, we put our dividing line down. And on this one, I see that I have more of the variable on the left, so I'm going to do that. I'm going to move it to the left, and I'm going to subtract 4k from both sides. And we get 3k plus 2 is equal to negative 10 because the 4k cancels out. So my next step is going to be to subtract 2 from both sides because that's the opposite of adding 2. And I'm left with 3k is equal to negative 10 minus 2 is negative 12. Divide both sides of the equation by 3, and we find that k is going to be equal to negative 4. Now, I would like you to try questions D, E, and F on your own, and then check them against my work in a moment. Okay, letter D, we start off with our dividing line down the center. And I have more y's on the left than I do on the right, so I'm going to subtract 7y from both sides. And we get that y plus 9 is equal to, that cancels out, and we're equal to 6. So now I'm going to subtract 9 from both sides, and I get y is equal to negative 3. Okay. Now, letter E. We have our dividing line, and I have more x's on the left than I do on the right, so I'm going to subtract 2x from both sides. And we get 3x plus 13 is equal to 22, because the 2x minus 2x cancels. Subtract 13 from both sides. We've got 3x is equal to 22 minus 13 is 9. And then we go ahead and divide by 3, and x is going to be equal to a positive 3. And letter F. Again, we start off with our dividing line, and I see that I have more k's on the right than I do on the left, so I'm going to subtract the 3k from both sides. Our 3k's cancel out. Negative 5 comes down. 7 minus 3 is 4k, and I have a minus 21. My next step is to add 21 to both sides, and I get that 16 is equal to 4k. And my final step is to divide by 4, and I get 4 is equal to k. All right, we're going to go on to the next page now and look at some word problems. So we have our example 2 is writing an equation with a variable on each side. And we've got a little story here. So an office manager spent $650 on an energy-saving copier that will reduce the monthly electric bill from the office from $112 to $88. In how many months will the copier pay for itself? So that's our question right there. In how many months will the copier pay for itself? Well, we're going to define our variable m equals months. And what does it mean for the copier to pay for itself? That means the cost is the same. So let's figure out what these costs are. Now, I know we're buying this brand new fancy copier, and that's going to be $650. And it's going to cost it $88 per month to run this fancy new copier. So one side of my equation is $88 times the number of months plus the cost of the copier itself. And we're going to set that equal to, we need to find out what the cost was before, and that's going to be $112 per month. Okay, so the old copier was running $112 a month. Now with this new copier, we need to add the cheaper rate that it's going to work with, but we also need to factor in the fact that it cost us $650 to buy it in the first place. So my first step is going to be draw my line down the middle as always, and then I'm going to subtract 88m from both sides. That cancels out, and we're left with 650 is equal to 24m. And then we just go ahead and divide 24 out. And what do we get? We get 27 0.083 repeating is equal to m. Now the question has said, after how many months will the copier pay for itself? So in this case, we need to round this up, and we're going to say at 28 months. Because after 27 months, there's still that 0.083 repeating of the cost that hasn't been made up yet. So it's really close at 28 months or 27 months, but 28 months would be the correct answer because at that point it is now paid off. You are now saving money from here on out on your electrical cost every month for running this copier. And then we have a little joke. So our next example, letter B, is a U-Try. We have Brad needs to rent a truck to move out of his house. One company charges a $50 flat fee to rent the truck plus 10 cents per mile driven. Another company charges $20 to rent a truck plus 30 cents per mile. After how many miles are the costs going to be equal? So this is a U-Try problem. I want you to do this on your own and then come back and check your work against mine. So letter B, let's pull out the vital information that we need. So one company charges a $50 fee to rent the truck plus 10 cents per mile driven. A different company is going to charge $20 to rent the truck and 30 cents per mile. And we want to know after how many miles are the costs equal. So we're going to define our variable m equals miles. You could use x, you could use whatever variable you want. So the left side of my equation, we have $50 fee plus 10 cents per mile. So that's going to be 50 plus 0.1 times m, times the number of miles. And that's going to be equal to, the second company is $20 plus 0.3 cents per mile. So my first step in solving this, we divide it up, and I see that I have a greater value on the right for the variable than I do on the left. So I'm going to subtract 0.1 m from both sides. And I'm going to get 50 is equal to 20 plus 0.2 m. Now my next step is going to be subtracting 20 from both sides. And we get 30 is equal to 0.2 m. And my final step will be to divide by 0.2. And when I do that, I get 150 is equal to m. We need to include our units, and so it is 150 miles. So if all of the driving that Brad is going to do is less than 150 miles, he's better off going with the company that's charging more per mile, but a lower starting cost. If his travels are going to be more than 150 miles, then he's going to want to go with the one that is more expensive to rent the truck, but is charging you less per mile as you drive. All right. Now we're going to move on to example 3 and 4, which is solving an equation with grouping symbols. And unlike previous problems where we've been able to do some kind of fancy math and divide without having to do distributive property, here we've got distribution happening on both sides. So that means we're going to have to use distributive property in order to simplify this equation. So we start off 7 times 4 is 28. 7 times negative x is minus 7x. Is equal to 3 times x is 3x, and 3 times negative 4 is minus 12. Now, my first step, I see that I have a positive value of the variable on the right, so I'm going to continue moving that way. And so I'm going to add 7x to both sides. And I get that 28 is equal to 10x minus 12. My next step will be to add 12 to both sides. And I get that 40 is equal to 10x. And my final step will be to divide by 10. And I get 4 is equal to x. Okay, now make sure when we're distributing, keys we need to remember is the second distribution. That's a place I've been seeing mistakes. And make sure we're multiplying and not adding. This right here tells us that we are multiplying this value. All right, letter B. I'm going to start off with my dividing line. And as I look at this, I have distribution I have to do, but then I also see there's some extra terms there off to the side here that I'm going to have to not forget about. So first thing, let's do the distribution. So we have 5y minus 20 is equal to 7 times 2 is 14y. 7 times 1 is 7 plus 3y. So on the right side, I need to combine like terms. I have 14y plus 3y, so nothing changes on the left. 5y minus 20 is still there. And now I have 17y plus 7. So I have more y's on the right than I do on the left, so I'm going to subtract 5y from both sides. And that gives me negative 20 is equal to 12y plus 7. Subtract 7 from both sides. Negative 27 equals 12y. And my final step, divide by 12. And I get negative 2.25 is equal to y. That could also be written as negative 9 over 4. Or negative 2 1/4. I would prefer this or this over the mixed number. I would prefer the improper fraction or the decimal approximation over the mixed number, just because I don't like mixed numbers. And really, when you're going for a decimal, I would only give me decimals. Really, the only time you should be giving decimals is if they're terminating decimals, meaning they end. So negative 2.25 is a terminating decimal. If it's repeating decimals, I would rather you give me the fraction because that is a more accurate answer than rounding a repeating decimal. All right. Now, letter C, we have a grouping symbol, but it's not the same one that you're used to seeing because it's the fraction bar. And remember, the fraction bar we treat as a grouping symbol. So the first thing I need to do is multiply both sides by that 4 so that I can clear the denominator of this fraction. So I'm going to get 20y is equal to 12y plus 16. My next step is going to be subtracting 12y from both sides. And I get 8y is equal to 16. And then we can go ahead and divide both sides by 8. And I get that y is equal to 2. All right. So if we go on to our next page, you'll have the 3 U-Try problems. Go ahead and work those. And when you're done, come back and check your work against mine. All right, our first example here, we've got 4 times 2 is 8a. 4 times negative 1 is minus 4 is equal to negative 10 times a is negative 10a. Negative 10 times negative 5 is plus 50. My next step is to get my variables to where they're going to be positive. So I'm going to add 10a to both sides. And I get 18a minus 4 is equal to 50. Add 4 to both sides, and we get 18a is equal to 54, which when we divide by 18 on both sides will give us that a is equal to 3. Okay. Letter E. We have a lot of things going on in letter E. So we start off with our dividing line. We start with distribution. 7 times 6 is 42. 7 times negative 2a is minus 14a, and I have a minus 12. 6 times negative 3 is minus 18a, and 6 times 1 is 6. And don't forget, we have a 3a out to the right-hand side. So now let's combine like terms on each sides of the equation. So combining like terms, we have 42 minus 12. So that's going to be 30 minus 14a is equal to, I have a negative 18a plus 3a, so that'll be negative 15a plus 6. So now I'm going to try to figure out where am I going to get my variable to be positive. I could either add 14 or I could add 15. By adding 15a, I will be able to get my variable positive. And I get that 30 plus a is equal to 6. So we're going to subtract 30 from both sides. We get that a is going to be equal to negative 24. Letter F, we are going to start off with this one by multiplying both sides of our equation by 6. And we'll end up with 3x plus 12 is equal to 6 times 4. So if we just do this off to the side, 4 over 3 times 6 over 1. So that's going to be 24 over 3. And 24 over 3 is going to reduce to 8x. So my next plan will be to subtract 3x from both sides. And I get that 12 is equal to 5x. Divide by 5. And I get that, well, we could leave it as just 12 over 5, or we could write it as 2.4. So it could either be 12 fifths or it could be 2.4. Either one would be an acceptable answer. If you wrote 2 2/5, that would be fine as well. I wouldn't like it, but I'll get over it. All right. So example 5 here is writing an equation with grouping symbols. So our first thing tells us we're going to find the value of x so that the figures have the same area. So we need to just remember that how do we find area of shapes again? Well, a rectangle is length times width, so we're going to have 5 times x plus 4 is equal to a triangle's area is 1/2 times the base times the height. Now, pay attention to the fact that I'm putting our binomials in parentheses here because that entire expression, x plus 4, is being multiplied by 5. All right, so now we're going to do our multiplication. So we need to multiply outside the parentheses first, and I'll zoom in so we don't need the picture anymore. So we have 5, and we'll do this distribution on the left-hand side. So we got 5x plus 20 is equal to 1/2 times 12 is 6, and then we still have the 2x minus 6. All right, now we do this distribution. We have 5x plus 20 is equal to 12x minus 36. Okay, so I'm going to subtract 5x from both sides. And we get 20 is equal to 7x minus 36. And then we add 36 to both sides. We've got 56 equals 7x. Final step, divide by 7. We get that x is equal to 8. Now, there are no units given in this question, so you do not need to include any units in your answer. All right, we have a U-try problem. Find the area of x so that the figures have the same area. So find the value of x so that the figures have the same area. They're both rectangles, so this should be relatively easy. Go ahead and try this one and then check your work against mine. So for the area of the square or rectangle on the left, it's going to be 10 times x. It's going to be equal to our 6 times x plus 3. And now we can go ahead and work this problem. So 10 times x is 10x, 6 times x is 6x, and 6 times 3 is 18. Our second step will be to subtract 6x because there are more x's on the left, but also even if 10x was negative, the variable is by itself on the left side. So we don't have any constants there, so we're going to get the variable to that side. So 10 minus 6 is going to give us 4x is equal to, those cancel out, and it's equal to 18. So our final step is to divide by 4. We get that x is equal to 9 over 2, or 4.5 centimeters, because we were asked what is the distance of the value. And so if it's 4.5 centimeters, our given unit, that will give us an area that is the same. All right, we're now going to go to our final page, and this is going to be the callback to our vocabulary words from the beginning of this lesson. So as we look at it, we need to start off by doing distributive property. So 3 times 4b is 12b. 3 times negative 2 is minus 6, is equal to negative 6 plus 12b. Now, my next step is going to be to subtract 12b from both sides. I want to get them to the same side. And what do I end up with? Well, 12 minus 12 is 0, so that cancels out. We're left with negative 6. And then negative 6, 12 minus 12 is 0, and it cancels out. So I have negative 6 is equal to negative 6, so this is an identity, which means that I could substitute any value I want in for the variable b, and it will always be a true equation. There's nothing that is untrue in this question. Any value I put in for the variable will make the equation work. All right, letter B. Let's take a look at what we have. We're going to need to do distribution on the right. So we've got negative 1 times 3. So we have 2x plus 7 on the left equals negative 3, and then negative 1 times negative 2 is plus 2x. So now I subtract my 2x from both sides, and I get that 7 is equal to negative 3. Well, that's just not true. We know that's not true, so this is no solution. And so on your assignment, if you get one of these special cases, you're going to either write identity or you'll write no solution. There's 2 U-Try problems here for you. Go ahead and do them on your own and check your work against mine. All right, so we're going to start off with, we need to combine like terms on the right-hand side. So we have m plus 8. We'll clean that up a little bit. M plus 8 is equal to negative m plus 2m is m. So negative 1 plus 2 is 1, plus 6. And now we subtract m from both sides. And we're left with 8 is equal to 6, which, while they are both crooked numbers, that is not true. So this is a no solution. And letter B, we have 2a plus 3, and we've got 1/2 times 6 and 1/2 times 4. So we have 2a plus 3 is equal to 1/2 times 6 is 3. 1/2 times 4 is 2. So 3 plus 2a. We subtract the 2a's. And we're left with 3 is equal to 3. So this one turns out to be an identity. That is the end of the Module 2.4 notes. If you have any questions, please feel free to bring them to class, and have a great day.